This meeting is being recorded.
Hello, today we are going to talk about gradient descent, stochastic gradient descent. So to start on that, we need to explain the normal gradient descent, which Dhruv will explain.
Thank you, Rakesh. I'll continue from here. So, before knowing stochastic gradient descent, we should know gradient descent because they are pretty much similar. Gradient descent is one of the most widely used machine learning algorithms. It's used to minimize the cost function. Gradient descent is a iterative algorithm which, in case of linear regressions, starts by providing a random y-intercept and a y-intercepts and a slope, which then slowly travels down the gradient and tries to minimize the cost function. Next slide. The best part about gradient descent is that the same algorithms can be used in multiple AI ML algorithms, such as regression, classification, clustering. Uh, Only the downside about gradient descent is that it doesn't work well with big data. The number of features, as you increase the number of features and the size of the data set, it becomes harder to compute the algorithm. This is where sc-
Stochastic gradient descent.
stochastic gradient descent comes in handy. Over to you, Leo.
Stochastic means random. SGD works as an optimizer to the gradient descent. In SGD, a few samples are selected randomly instead of the whole data set per iteration, and this reduces the computation time. It can be applied to large-scale and sparse machine learning problems often encountered in text classification and NLP. And the randomization helps to prevent duplication of examples and avoid circles.
Okay. So this is a slide where we shows how there is different kind of minimas values we can calculate through the stochastic gradient descent. So there are three different minima value in each place, and we can calculate differently based on it through the stochastic gradient descent, which we shortly say SGD.
For this example, it used the sklearn to implement SGD and Boston housing data set from Kaggle. The data set size is 30% and the training size is 70%. The maximum iteration is 1000 and the tolerance set to default value, and the mean square error is 0.049, which is beautiful result.
Okay. So over to you, Sanuka, about the limitation.
Yeah, thanks, Rakesh and Leo. So when it comes to the gradient descent, there are some limitations included in that as well. So main points are that due to the increase in noise, it's going to consume more time to reach the goal, and also like there's like number of frequent updates that's happening on the system. So there's a possible way of going in the wrong direction because of the updates. And since all the data of the system is used on one data set, the the updates on the system is really expensive because of the time allocation and stuff. And since it's work with only one cycle, example on every cycle, the range is really high on the limitation system. And those are some of the main points of the limitation of the system. Yeah, on the next slide. And if you want to get more reference on this system, to get like more knowledge of the system, you can refer these websites and develop your skills even more. Thank you.
Thanks for watching. Thank you.